Next one is output offset voltage. VOS, output offset voltage. The effect of input bias current, that is IB. IB is equal to average of two input currents of the operational amplifier. Average of these two currents, input bias current. Input offset voltage, IO, input offset voltage is equal to the algebraic difference between these two base currents, IB1 and IB2, and input offset voltage. Input offset voltage. Input offset current is the algebraic difference between these two amplifier, these two op-amp currents. Input bias current is the average of these two input bias currents, input base currents. The algebraic difference between the currents into the inverting and non-inverting terminals is referred to as input offset current. Input bias current IB is the average of currents that flow into the inverting and non-inverting input terminals of op-amp. That is IB1 plus IB2 by 2. Because of these three, input bias current, input offset current, input offset voltage, is to add the error to the expected DC output voltage. These parameters produce the output voltage when both the input terminals are grounded. One is resistance R, IB1, IB2. This terminal is grounded. Non-inverting terminal of the op-amp is grounded. This one is inverting terminal of the op-amp is grounded. Non-inverting terminal of op-amp is also grounded. Due to these factors, this one is IB, this one is IB1, and this one is IB2. These parameters produces the output voltage when both the input terminals are grounded. Inverting terminal as well as non-inverting terminals of the op-amp are grounded. Therefore, due to these parameters, input bias current, input offset voltage produces some output voltage, V0. V0 not equal to 0. The DC voltage present at the output terminals, this is the DC voltage present at the output terminals when both the input terminals are grounded. Both input terminals are grounded is called output offset voltage. This is called as output offset voltage. The output voltage caused by input offset voltage. So the output offset voltage caused by input offset voltage. This can be VIOS, can be either positive or negative with respect to ground. Similarly, the output voltage, the output offset voltage, due to input bias current, IB, can also be positive or negative with respect to ground. IB is either positive or negative with respect to ground. If these output voltages are different polarity, due to this VIOS, output voltage is plus. Due to this IB, the output voltage is minus. If these output voltages are different polarities, then the total output voltage is very small. Then the total output voltage is VO total output voltage is equal to VOOS minus V1 OOS minus V2 OOS. If these voltages are same polarity means plus V1 OVS plus V2 OVS. Same polarity, then the output offset voltage is very large. Total output offset voltage is very large. Thus, the output offset voltage is given by V naught due to VIOS input offset voltage, V naught due to input bias current, V naught due to input bias current. Because of these two parameters, some unwanted output offset voltage is produced. How to eliminate this output offset voltage? First one, compensate the output offset voltage due to input bias current. Due to input bias current, V naught output offset voltage is produced due to input bias current. To compensate the output offset voltage due to input bias current, a compensating resistance is used. Here, this is the compensating resistance is used as shown in figure. It is denoted as R compensation. This is called offset minimizing resistor. This is called as offset minimizing resistor. This output offset voltage is undesirable one. This output offset voltage is due to input bias current, input offset voltage. While the effect of offset voltage is nullified using voltage compensating network. Compensating network shown in figure here. For many op-amps, the offset compensation pins are provided to nullify the offset voltage. Consider 741 IC, 8 pins are there here, 4 pins here, 4 pins. First pin and fifth pins are particularly called as offset pins. These two are offset pins. For many op-amps, the offset compensation pins are provided to nullify the offset voltage. The manufacturer specifications must be referred to use these compensation pins. Some manufacturers decide 2, 3, 7, 5 like that. The manufacturer specifications must be referred to use these compensation pins. For example, in case of IC 741 op-amp, the pins 1 and 5 are provided as compensation pins. The manufacturers recommends that a 100 kilo ohms potentiometer must be connected between pin 1 and pin 5. This is the wiper. A wiper must be connected to the negative supply pin, that is 4. Negative supply means minus 15 volts. A wiper pin of the potentiometer is connected to the negative supply pin, which is pin number 4. By adjusting this potentiometer wiper, the output voltage is 0, that is nullified. This is the compensating network. This one is compensating network. Compensating networks are used to nullify the output offset voltage. Finally, the output offset voltage is due to input bias current, input offset current, and input offset voltage. Input offset voltage. Input bias current IB is the average of the currents which are flowing into the inverting and non-inverting terminal of the op-amp. These two currents are IB1, IB2. IB is equal to IB1 plus IB2 by 2. That is the input bias current. Input offset current is equal to algebraic difference between the currents into the inverting and non-inverting terminals. Inverting and non-inverting terminals. IIO is equal to mod of IB1 minus IB2. What is the slew rate? Slew rate is an important parameter of the op-amp. The slew rate of op-amp rate is maximum rate of change of output voltage with respect to time and is measured in volts per millisecond, volts per microseconds. Maximum rate of change of output, that is delta V naught, with respect to time delta t, and is measured in volts per microseconds. Voltage is measured in volts, delta t is measured in microseconds. Consider unity gain op-amp. Interfollower unity gain op-amp. Unity gain op-amp. Why it is called as unity gain op-amp? The output here, output voltage, this one is output voltage, is cut back given to the inverting terminal of the op-amp. Here, this one is input voltage VA. According to Ochwal concept, output voltage is same as input voltage. Therefore, gain of the op-amp is equal to output voltage by input voltage. Both are same. Therefore, V naught by V naught, the gain of the operational amplifier is 1. That is equal to 1. Open loop gain. This is the slew rate. Here, observe this is the input waveform. This is the output wave. Output waveforms are two types. Output waveforms are two types. First one, this is the slew rate ensures that the change in the output voltage occurs simultaneously with the changes in the input voltage. The change in the output voltage occurs simultaneously with the change in the input voltage because these two waveforms shapes are same without any distortion. The rate of change of output voltage is same as the rate of change of input voltage without any distortion. Suppose if the output does not change with the same rate as input, then there occurs distortion in the output. The output rate of the output waveform shape is not follow the input waveform shape. Some distortion is result. Some distortion is result. The square waveform is applied to that non-inverting terminal of the op-amp, and frequencies are changes rapidly. Observe the output waveform shape. If the output waveform shape follow the input waveform shape, therefore the slew rate is maximum. The slew rate is maximum. If the output waveform shape does not follow the input waveform shape, some distortion is results. Some distortion is results here. Here, the output changes from 0 to 5 volts rapidly as input change from 0 to 5 volts. Okay. In the second case, some time will require to change the output voltage from 0 volts to 5 volts as input voltage is changed from 0 to 5 volts. Some delay is there. Therefore, output waveform changes will not follow the input waveform changes. Consider circuit using op-amp having unity gain. Unity gain A is equal to 1. The output is same as the input. This is the input. This is the output. The output is same as the input. The output is same as the input. If the input is a square wave, the output has to be square wave. Input is a square wave, output has to be square wave. But this is observed for certain frequency of input. This is observed certain frequency of input frequencies. Due to slew rate of an op-amp for a particular input frequency, output gets distorted. At certain frequencies, the output at a certain frequencies, output voltage, the changes in output voltage occur simultaneously with the changes in the input voltage. At certain frequencies, the changes in the output voltage occurs simultaneously with the changes in the input voltage. At a particular frequency, the output does not change with the same rate as the input, then there occurs distortion in the output. Due to slew rate of an op-amp for particular input frequency, output gets distorted as shown in figure. Then observing such distorted waveform on CRO, the slew rate can be obtained as up to certain frequencies, the output voltage, the changes in the output voltage occur simultaneously with the changes in input voltage. The changes in the output voltage occurs simultaneously with the changes in the input voltage up to certain frequencies. At a particular frequency, the output does not change with the same rate as the input. The output does not change with the same rate as the input. Then there is occurs distortion in the output. Slew rate is defined as we know that the change of output voltage with respect to delta T, volts per microseconds. If delta T is equal to 0, delta V naught by 0, that is slew rate is infinity. If delta is 0 means output waveform shape is same as the input waveform shape. That means without any distortion. Therefore, delta T should be very less. Ideally, it is 0. Practically, it is not 0. It has some value. Delta T is low value. Slew rate is maximum. This is the slew rate. Generally, slew rate S is equal to infinity. This ensures that the changes in the output voltage occur simultaneously with the changes in the input voltage. That means input is a square waveform. Output is also square waveform. The changes in output voltage occur simultaneously with the changes in the input voltage. The slew rate is the important parameter of amp. When the input voltage applied is step type, that means square wave is nothing but combination of two steps. Step type, which changes instantaneously, as input changes instantaneously. That means input waveform frequency changes. Then the output also must change rapidly. As input changes. That means output waveform shape is same as the input waveform shape. If output does not change with the same rate as input, output is like that. Some delay is there here. If the output does not change with the same rate as the input, then there occurs distortion in the output. This is the output. Such distortion is not desirable one. Infinite slew rate indicates that output changes simultaneously with the changes in the input voltage. Infinite slew rate means delta T equal to 0. The output voltage changes occurs simultaneously with the input voltage changes. Therefore, the slew rate is infinity. The parameter slew rate is actually defined as maximum rate of change of output voltage with time is expressed in microseconds. Slew rate is an important parameter. Slew rate indicates how rapidly the output of an op-amp can change in response to changes in the input frequency. The slew rate changes with change in voltage gain. Generally, A is equal to 1. A value changes, slew rate is also changes. One of the drawbacks of the 741C is its low slew rate. That value is for 741C often the value is 0.5 p microseconds. Generally, the slew rate should be very high value. Delta T is low, slew rate is very high. In some cases, ideal case, delta T is equal to 0, slew rate is infinity. Delta T is equal to 0 means the changes in the output voltage occur simultaneously the changes in the input voltage. Output voltage changes follows the input voltage changes. Output voltage changes not follow the input voltage changes. Some distortion takes place. Some slope is there. Some slope is there. Suppose this one is a unity gain op-amp, A is equal to 1. VA is the sine wave is applied here. The output waveform shapes are either sine wave or triangular wave. Triangular. Triangular wave means some delta T is there, some delta V is there. Slew rate is equal to delta V by delta T. If delta T is equal to 0, the changes in output voltage delta V naught by 0. That means infinity. Therefore, the shape of the output waveform is same as the shape of the input waveform with delta T is minimum value. Slew rate is maximum value. With this two parameters are completed.